I'm Miranda Vargren, and I'm a 6th grader at Wilson Middle School.
I'm Julia Fairchild, and I'm a 6th grader at Wilson Middle School.
I'm Simra Babu, and I'm a 6th grader at Wilson Middle School.
Sure.
So the project that we did was the magical bottles. We named it this because we thought that the bottles seemed kind of magical because they changed up everything and stuff. So we're going to show you the traffic light bottle experiment and the blue bottles experiment.
Okay, the blue bottle experiment. The blue bottle experiment is the chemical reaction. A chemical reaction is a process that involves a rearrangement of the molecular or ionic structure of a substance, as opposed to a physical or nuclear change. This experiment requires
methylene blue, sodium hydroxide, water, and glucose.
So the steps what you will be doing for this experiment is you will be dissolving 10 grams of glucose into your half-filled 1 liter flask with water, and then you will put 6 grams of sodium hydroxide and dissolve it in there, and then you will mix it up until it's well combined, and then you will put 4 to 5 drops of methylene blue into your thing, which we have already done. So then when you let it sit, it becomes transparent, and when you shake it like this, it becomes blue. And it takes a little while to get transparent, so let's just move on while you're watching that.
And as you can see, it became clear.
Yep. How it works.
By shaking the solution, you increase the concentration in the oxygen, which therefore making the methylene blue come back to its original blue state. When the bottle is taken in all the oxygen, it transforms back to a colorless state. This transformation can be repeated as many times as you want within reason by just shaking the color changing bottle.
This experiment is used to figure out the kinetics of the chemical reaction and therefore the process. This demonstrates the chemical reaction of oxygen with methylene blue. Using this demonstration, the solution created is transparent when still and is blue and opaque when shaken. The pigment of the liquid transforms, as seen in this experiment, are reversible and at times irreversible. The oxidation and reduction changes are that the oxidation increases in oxidation number and the reduction decreases in oxidation number. So this oxidation reaction is also known as a redox reaction. In a redox reaction, the oxidation numbers are altered, and the stimulation that we used was methylene blue.
The traffic light experiment. What it is. The indigo carbon in the alkaline solution takes on a reversible redox reaction when mixed with the oxygen from air.
This experiment requires glucose, sodium hydroxide, water, and indigo carbide. So what you do is first you want to have 700 grams of water. Then you add your sodium hydroxide. That's 10 grams sodium hydroxide.
And then shake it up to get it.
Then you want to shake it to mix it well.
And make sure you close the cap on tight because some of the
Sodium hydroxide, make sure not to keep it open a lot because it will react with the air and become a different substance. Now she's going to add the glucose. That's 6 grams of glucose.
Little double.
And then you'll mix up to get it well dissolved.
So we could not get indigo carbon. Indigo carbons are really hard, really strong chemical. So they will not sell it to people unless they're certified teachers. So we couldn't get indigo carbon. So we tried a new experiment with
Potassium
permanganate, and that is used instead of indigo carbon. Yeah. So this is just a pinch of potassium permanganate and water, and if you pour it, you'll see many colors change.
So you have to watch carefully because this is only a one-time experience. So it turns from green to orange, orangish red, and then it turns to yellow. And yellow is the last color that you'll see.
This experiment is not cannot go more than once. Yeah.
Okay, the traffic light experiment. What is it?
How long? How much more is it?
Like 2 more minutes.
Okay.
You're given like 3 minutes for each candidate. Summary.
So why this works is the potassium permanganate has when you pour it in, it's like a redox reaction, also a chemical reaction. But when you pour it in, it makes a new chemical called manganese dioxide. And that manganese dioxide floats to the bottom after a while, and as you can see, this starts to get a bit clear. So, and that with the color changes with that potassium manganese, or it wouldn't really change at all if you put like some other thing. Yeah.
Thank you.